Okay, so in chapter 7, we already knew, for example, the population mean, and we were trying to figure out the probability that our sample mean was a certain value. For example, the population mean we know is 10, so what's the probability the sample mean is 12 or greater? Something like that. Now we're going to reverse direction. We want to make an inference about the population based upon our samples. So it's a totally different thing here. So before constructing any confidence interval, there's 3 conditions that we need to meet. So 3 conditions. And then I'll tell you the formula for it, and we'll do an example of interpreting them. We're not even computing them, we're just interpreting them. So there's 3 conditions. Number 1, random. So it's RNI, random, normal, independent. So number 1, random. Your data must come from a random sample. Otherwise, you can't make an inference about the population. So data comes from a random sample. Otherwise, we just really can't do anything. Data comes from a random sample. 2, normal. Your sampling distribution needs to be normal. So normal sampling distribution. Not necessarily the population, but the sampling distribution needs to be at least approximately normal, if not exact. Approximately normal. So there's 2 cases. If we're talking about proportions, this will be a good review. If we're talking about proportions, then the condition we use to figure out if the sampling distribution is normal is either, what is it? Good. NP greater than equal to 10 and N1 minus P greater than equal to 10. So that's for proportions. For means, when we take the mean, the sampling distribution is already exactly normal if the population distribution we started with is normal. So there's 2 cases. So the sampling distribution is already exactly normal. If the population distribution was normal to begin with, if population, I'm going to abbreviate a little bit, distribution is normal. Otherwise, what theorem do we have? Otherwise, the CLT says the sampling distribution will be approximately normal if n is sufficiently large, greater than equal to 30. Otherwise, I'm just going to write, otherwise, we already know enough to just say, otherwise use the CLT. And we know what that is. Okay, so that's the second condition, and the third, before we can even start constructing confidence intervals, is independence. The trials need to be independent, and this is what you've been saying is the 10% condition. So you can say it either way. 10% condition. So as long as the sample size is not greater than 10% of the population, it won't matter that we're not replacing things, because normally we don't when we take a sample. So yes, we want our sample size to be large because then it's going to be more accurate, but not greater than 10% of the total population. Otherwise, we can't calculate the standard deviation. So random, normal, independent. This is the 10% condition. So I'm gonna write it. I'm gonna write out what that is. So when sampling without replacement, which is usually what we do. When sampling without replacement, that affects the probability. When sampling without replacement, the sample size n should be no more than 10%. Should be no more than 10% of population size n, of population size n, to use the standard deviation formula. To use standard deviation formula for our statistic. And the statistic is whatever we're trying to figure out about the sample. Okay, so those are the three conditions. I'm going to move on to the second page. So 3 conditions for confidence intervals. Here's the formula for confidence intervals right here. Okay, formula is right here for confidence intervals. You basically have your statistic, and that's like, we're going to do an activity in a second with that, but that's like your best guess, your statistic from the sample. Since you don't know what the true answer is for the population, you do what's called the point estimate. From it, you take a sample, point estimate, and that's like your best guess. The best guess. And then for the confidence interval, it's plus or minus. What we call the critical value is the number of standard deviations you want to do plus or minus. So critical value, like 2. If you want 2 standard deviations, plus or minus. So plus or minus the critical value, it's usually 1 or 2, times the standard deviation of the statistic. Standard deviation of statistic. And this will make more sense when we do examples, but I just want to give you the formula for confidence intervals. And then this whole thing, the number of standard deviations plus or minus, like within 2 standard deviations, that's called the margin of error. Margin of error. Okay, so that's the only formula for this. And now we're going to look at how the way you word your answers for confidence intervals, it kind of follows a formula. There's like a sentence structure for it. So I'm going to give you both of those, and then we'll do an example. Okay, so here's, whenever you're asked to interpret a confidence interval, confidence interval, and then there's the confidence level. Confidence interval, it's like this. So here's what you say. Here's like exactly how you're going to write this over and over again, so you practice. So let's say I have a 95% confidence interval, which is typical. So you would say we are like C% confident. This is how you would answer. We are, so let's say 95% confident. We are 95% confident that the interval from blank to blank, this is the most important part, from blank to blank, whatever the interval is. We'll do an example in just a second. We are C% confident that the interval from blank to blank captures or contains, captures the actual value of the, and then I'll put in bracket, because you have to put it into context, whatever you're talking about in the problem. So that would be the population parameter of interest that we're trying to find. Population parameter of interest. Like the population mean. Okay, and that's the interval, and then the confidence level. This is how you interpret the confidence level. That's the interval, the level. This means C% of all possible samples. C% of all possible samples of a given size from the population will result in an interval. The wording is really important. Will result in an interval plus or minus whatever your margin of error is, will result in an interval that captures the unknown parameter. We don't know exactly the unknown parameter. We're just trying to get close. Will result in an interval that captures the unknown parameter. The unknown parameter. And that's it. Those are the main notes for 8.1. Let's do one example. There's one from, hopefully you printed it. If not, you can print it later or write it. So example of interpreting a confidence interval is here. So I'll just write the title since you already have it in front of you. Presidential approval ratings. Approval ratings. Okay. So I am gonna